290,000 square miles in extent, or over 3 times the size of England and Wales, lies in Central Africa. It forms a huge tableland between 3,000 and 5,000 feet high and covered for the most part with thorn bush. Its chief source of wealth is the copper exported from its mines. The copper-bearing rock lies under a flat plateau in the form shown in this section and is indicated by the white line. The first step in the mining of this rock is to sink a shaft just outside the main body of the copper ore. At the top of the main shaft is the head frame supporting the gear which carries the miners up and down the shaft and also brings up the... These Africans, boys as they're called, are about to go below to start their shift, which lasts for 8 hours. They line up in groups and walk forward in single file towards the lift which will carry them down the shaft. As they file past the white overseer, they are counted to make sure that only the right number are carried. The lift, which is called a cage, has 2 decks, and no more than 60 men may be carried on each deck. In the mine itself, the boys work in small teams supervised by European miners, each of whom may control several teams. Underground, the miners set off along the main tunnels of the mine and weld it. These main tunnels are driven from the shaft towards the copper-bearing ore. From these, other smaller workings are made in which the ore is mined. The African mine boys often have a long walk along these tunnels to their work. Their chief tools are drills of various types driven by compressed air. These are used to cut holes in the rock so that it can be blasted down by explosives. The cutting edges of these drills, which are sometimes diamond-tipped, are kept cool by water passed through the hollow center. The copper ore does not run in seams as coal does, so the miners don't have to work in a confined space. Indeed, so much rock is brought down by continued blasting and drilling that very large caverns are cut out. In time, such caverns become so big that one can see drilling being done on several levels at the same time. Towards the end of the shift, drilling is stopped and the drills removed, ready for the explosive charges to be laid. Dynamite, or gelignite, is rammed carefully into the drill holes. An experienced African called a boss boy generally does this work, but the actual work of setting off the charges is done by a European miner. When all the charges have been laid, everyone is cleared from the cavern, and the European miner lights the fuses in the order in which he wishes the charges to explode. The explosion causes large masses of rock to be broken off. This rock collects at the bottom of the cavern and is later gradually drawn off through small steep cuttings made to the level below for the purpose. From these cuttings, the ore can be loaded directly into trucks. These trucks are driven rapidly along the well-lit main tunnels back towards the shaft. Here there is another cutting called an ore pass, through which the ore will be sent to the bottom of the shaft. Each level of the mine has an ore pass. As the trucks pass the cutting, they are tipped automatically by means of this ramp. At the top of the ore pass is a grid called a grizzly, which holds back over large pieces of rock. The diagram shows how the ore passes are connected, so that all the ore collects at the bottom of the mine. There is a grizzly at the top of each ore pass. At the bottom of the lowest ore pass is a chamber which controls the flow of ore. It is known as a flask, and it holds enough ore to fill the 10-ton skip. The miner in charge thus measures out the ore in 10-ton loads. First, he allows the flask to fill. Then he empties its contents into the skip, and the ore is hoisted rapidly to the surface. Once above ground, the ore is tipped into a large storage bin, from which it can be drawn off as required. At this stage, the ore consists of fairly large pieces of rock in which oxides and sulfides of copper are present. Before the copper can be extracted, the ore must be ground to powder by a series of crushers and mills. Here, the ore is being drawn off from the storage bin. The crushers, which are all something like this one, act like giant pestles and mortars and break the ore into small pieces. Crushing mills then grind these pieces down into a fine powder called concentrate. Here, the concentrate is being fed into the top of a furnace. In the intense heat, it becomes molten, and the impurities float on the surface in the form of slag, while the liquid mineral sinks to the bottom, where it can be run off separately from the waste. At this stage, the mineral is called matte. Here, the matte is being run off into steel ladles. When enough matte has been run off, the tap hole is plugged by means of a clay dolly. The matte is now transferred to the converters, which turn it into metallic copper. These converters are large fire-brick-lined cylinders through which air is blown. The action of blowing air through the molten mass oxidizes it into metallic copper and into iron oxide, which is taken off as slag. During this process, great volumes of the gas sulfur dioxide are also given off. The molten metal, now almost pure copper, is cast into molds. The molds are rapidly cooled by spraying continuously with water. The boys chip the rough edges off the molds, or cakes as they're called, and the chippings are returned to the converters to be melted down again. The product, now almost completely pure, is known as blister copper.